Hello everyone, in this video we are going to discuss about compliance and elasticity. Compliance is the ability of the lungs to expand. So it is directly proportional to the change in volume to per unit of change in pressure. It is very high in conditions where there is less recoil of the lungs. That is, in emphysema and aging it is high, and in conditions like fibrosis and pneumonia it is low. So whenever there is steep slope it is more compliance. So the clinical impact is it is ability to expand. So whenever there is effect in the expiration, it is affected. So surfactant increases the compliance. We have to remember this. Next is elastic recoil. It is inversely related to the compliance. It is tendency of the lungs to collapse after inward stretch. So tendency to collapse is the elastic recoil and tendency to expand is the compliance. So it opposes the expansion and helps air to push out. It is high in restrictive conditions like pulmonary fibrosis because there is strong recoil there. It is low in conditions like aging and emphysema because there is less elastic recoil and floppy lungs. So there is flat curve because of poor compliance and more recoil. It affects the expiration. And recoil opposes the filling and drives the passive expiration. So at functional residual capacity, inward pull of the lung is equal to the outward pull of the chest wall. So the system pressure is equal to the atmospheric pressure. So it is at a stable state in the functional residual capacity. So we have to know one concept called as hysteresis. It says that there is different curve for inspiration and expiration because of the surface tension. So this is the inspiration curve and this is the expiration curve. There is change in this because of the this is called as hysteresis. The difference in the curves in both inspiration and expiration at FRG, that is functional residual capacity, it is equal. So we have to see this curve. It is a pressure volume curve showing chest wall, lung and chest wall and lung, that is the respiratory system. So we have to remember one thing, that lung will always try to collapse, chest wall will always try to expand, and lung plus chest wall is the respiratory system. So lung, here in the graph we can see it is showing the pressures. It's 0, this is negative pressure and this is the positive pressure. So it's lung, it always starts after 0 pressure. So this is the dotted line showing the lung curve. It is starting at the positive pressure. So it will always try to recoil. So always the direction of it is always inward. So we have to know that it needs positive pressure to expand. That's why it will start after the zero value. At FRC it wants to collapse inward. Here at FRC the lung will try to collapse inward. So coming to the chest wall. So the quality of the chest wall is to expand. So it will start at a negative pressure. That's why it will help in drawing the air and also increase in the expansion. So the chest wall curve, it is starting at a negative point here. So it is at minus 40 here. So it will always have a recoil outward at low volumes. So at low lung volumes it wants to spring outward and flattens at high lung volumes. So that is same. At low volumes it wants to expand, but at high volumes it is getting flattened here. That is chest wall. So lung plus chest wall is the respiratory system. So here it is the solid line. This solid line is showing the chest wall plus lung. Here it is at FRC it is completely balanced. That is, the lung is trying to recoil and the chest wall is trying to expand. So they will equalize here. So we have to remember is lung will try to recoil. So it will start at a pressure positively after 0. So because it needs positive pressure to expand. Chest wall, it starts from a negative pressure because at low lung volumes it will try to spring outwards. So lung plus chest volume, it is the respiratory system. It will be balanced at FRC.